Hello guys, welcome to another episode of the on-demand series. In this video we want to see how we can develop plugins and extensions for FreeFEM, the finite element computation language. And it means that how we can interface some external C++ codes to our FreeFEM scripts, which can be very useful for some applications. Let's go for it. In the video that we compared FreeFEM and Phoenix, I said that one of the advantages of Phoenix to FreeFEM is actually the fact that Phoenix can be coded inside C++ and Python directly, and it means that you have access to the whole ecosystem of Python or C++. But FreeFEM is a domain-specific language, DSL, and it means that you have an isolated environment and you start to code inside that environment. And there are lots of applications that you need to interface some external codes for functionality that is not available in FreeFEM. And it happens a lot. I will show you a lot of examples later, from the works that I have done in FreeFEM required an interface to some external codes or libraries. And in this video, I want to show you how you can do that. It is quite simple, especially in Linux platforms. On Windows, it can be a little bit more complex, but in Linux, that is quite straightforward. And then, in this video, I want to show you how you can create some, functions in C++ and then call them inside FreeFEM. So let's start with, creating a simple script. So I go to desktop, desktop, and then I create a new directory here, test. Can be a good name. So I go inside test, and here I start to create a test script. That is fine. So I am here, so test.edp, and I can open it with, with Atom, for example. So here I can start to create my FreeFEM scripts. We will have, dedicated tutorials on FreeFEM, which is actually an introduction to FreeFEM concepts. We already discussed FreeFEM in one of the videos of the Finite Element series, in which we developed the code for some transient heat simulations in FreeFEM. But in this case, I will want to have like a very simple 2D mesh, and on top of it, I want to show you how you can call external code. So that's it. So I create a mesh in this square function, the square geometry, and then inside that, which is actually between 0 and 1, so with the edge length of 1, and then I have 5 elements in each edge, and then I create a finite element space on it. This is the way that I usually, name my things in FreeFEM, but it is not something you see in the documentation. That's fine. You can go for whatever you like. For mesh 1 and P1 elements, meaning that we have like first order elements and we have degrees of freedom on each node. We will discuss all these things in the finite in the FreeFEM series. And then we can define, something like on the space P1, we can define UH, and it can be like, something like instead of 0, I will assign 5 to that, or let's say 6, because I don't want to have a lot of 5s here. And then I can plot UH. And that's, a complete FreeFEM script, and I can run it by calling FreeFEM++. I've already showed you how you can install FreeFEM, how you can compile it. So refer to that video if you want to install FreeFEM in your system. And then I can call test.edp. So this is, the geometry by pressing M on the keyboard, like mouse, M in mouse. I can show the edge, the elements, and then with F, I can fill it, and I can see the color bar, in this case, the legend, and in this case, you can see that everything is filled with 6. So that's it. And then I want to have like some external codes to be linked to that, like a code that instead of, UH equals 6, I want to assign assign some values coming from external C++ codes. And for doing that, I have already developed the plugins here. I don't want to, write the codes right now. So I copy maybe first the test function, which is actually a function without any with some parameters. I will show you what I mean. So yeah, I open it here. And as you can see, this is the code. It's a very, very simple code that we can use to do what we want outside of FreeFEM and then link it to FreeFEM. So this is actually the function that does that linking. As you can see, I have some global objects and that I write on the terminal that is initializing, although this is not important. And then I add two functions, two new functions to let's say to this plugin. So I have a couple of includes here and then some namespaces. These are not important, these are required. And then this is an important function actually, that is a header file that is a function.h or hbp, which contains all the function definition that we need here, including this one operator, 1s, which means that, we have like a function that has only one input, and then we have access also to the data that comes from the mesh using this object. And then I have also operator 1s that doesn't have access to mesh objects, which is print here. As you can see, these are generics, templates in C++. Generic is the term that is used in C# and not in C++. In C++, these are templates. So the template for the function that accepts, returns double, because this is usually the exit code of the function or the return type. Or anything that it want to return, and then string that is actually the input. And by defining that, I want to have like a print function. I want to show you how you can easily pass strings also to external C++, and in this way it is passed via a pointer, and then it's printed on the terminal. And then for the function check, which has a simple name here, you can see that check here, also check here. This is the name that C++ will understand a function later on. For the check, it is double, meaning that we pass, I am able to pass it via reference to this, a constant reference, and then I can read back a double. So I have two functions here, and then after the init file, after the init function, I call this macro, and then it initializes everything. So this is the C++ code. You can see that it is very simple. I have defined these two functions, and this is something that is always there. You don't need to care about this. And there are other types of functions. You can in a function.hpp you can explore a file or the documentation of FreeFEM to see other types. You can have like 2 parameters, 3 parameters, and also different return types. So yeah, these are the codes. And then this is an important step. FreeFEM comes with, with a script that is actually FFCPP, C++, that does, if I want to see where is that, you can see that it is here. So I can say, like I can open it with cat or less to be printed on a screen only. You can see that this is a bash script sh that it tries to build some libraries, some shared libraries out of codes, and what it does is actually finding all the FreeFEM let's say headers, dependencies, and defining all the compiler prefixes and switches and configurations. You can see that these are defined here, and then depending on the user configuration, because there are some as you can see here configuration available to the user, it tries to build the compile command and then call it. So I press Q. And then yeah, this is the thing that I need to call on this file. So test function, and then I press enter, you can see that these are actually the code, the commands that this script executes. So yeah, there are some applications that you want to embed it inside another makefile or another build procedure. So these are really very simple compile commands. You can see that this is G++ compile only. We have already discussed all these things in a dedicated video. For building with GCC toolchain, and then it's compile only, creating the O file, intermediate file here, and then using that O file to create, this is switch O to define the output name SO file, which is actually the shared library. So this command, this is not required anymore, and then now I have this SO file here that I can load easily inside FreeFEM. So you can see that I can say load test function. This is the name of this shared library, and then super easy. I can say I don't want to have the plot here for now, and then I can say print. That is really like hi. I wanted to say that it's really like the print function that does nothing but putting the passed argument to the terminal. And this is a really standard std library in C++, the way that it writes to the terminal. So if I know, if now I run my FreeFEM script like this, I will see that this is printed here, meaning that especially if I run it with v0 to you can see that this is initializing because of this. And then this is high that I have printed here. And then similar to that, instead of this, I can say check 6. So now I can have the plot back because, I write it, and then you can see that FV, this is, 6 value assigned to everything, because this function does nothing but returning the value that is passed to it. So when I say check 6, it means that just evaluate, just assign 6 to any degree of freedom in this variable, and then I plot it, so you can see that how easy it was to pass arguments to FreeFEM. Now let's make it a little bit more complex, like by defining some more advanced functions. So I have, another file here which does some trigonometry related computation, but, this is the function. There is one important difference here in comparison to this one. As you can see, it doesn't accept any input, and it works only based on the values that it reads from the mesh. As you can see, I construct a mesh point, structure. Actually, it is a main point stack based on the stack that is passed to this. There is nothing that we need to do with this in FreeFEM. FreeFEM automatically passes this to this function. And then I can read the X and Y values of each node, in this case, because this is first order, of each node of the mesh. And then I can return the sine of X multiplied by cosine of X. And, these functions, I think they are available in FreeFEM. But yeah, I told you later I will show you more examples of these plugins. So you can really, it can come from an external library, something that does some real computation. Or for example, in one of the applications, I combine it with some thermodynamics-based calculators. And then I was calling those, the function of that library or the solver from within FreeFEM code using this technique. So you can see that it's possible also to have functions without any argument, but there is one issue here, and that's actually the fact that 0 argument is not defined in a function. So for doing that, you need to put a code like this, which is available in FreeFEM examples, but you can also find this in the GitHub with the link in the description below. So I need to define this class with a template that I can, you know, put it here, like class one operator 0s, and then with just double as a return type. And this is the name of the function, and this is the function name that it can be read inside FreeFEM. And then the same thing, initialization, still initializing, I printed here, so we will have two initialization, and then I can easily compile this function. So if this definition is not there, then this function, this code will not compile. And the details of this is not important at all. You don't need to deal with that. It's actually, you know, some template, again, template structures and pathing some, you know, some the C++ functions to some internal structures of FreeFEM. So you really don't need to deal with this. And yeah, this is what we are concerning about. This is a trick function, and I want to show you how easy you can use it here. So yeah, so now I need to compile it first. So ffc++ for the trick, I compile it. Now I have, you know, this trick so here, which is this one, trick function so, and I can delete this O file because this is an intermediate file generated with this flag. It's compile only, and then I can load it here. So very similar to this, I can have like now trick instead, and then instead of this one, or I can have two, let's say one we check for this one, and then this one can be like UH2. It doesn't really matter, and then it can be like just trick. And for that, you know, you can see that there is nothing here. Of course, this is a function, so we need to put this parenthesis, and then there is nothing passed to this. And even stack that was here is automatically passed. So FreeFEM takes care of that, and then we don't need to do anything. And instead of UH1, let's plot UH2. We can plot both, or I can simply comment this out. And then it's time to run a FreeFEM scripts test.edp. And wow, you can see how nice this is computed from, you know, from the external C++ code, and this is, you know, the mathematical computation is carried out by that external library, which is this one, which comes from this source code. And then if I, for example, change these things to something more, you know, a little bit more intensive, a finer mesh, I run it, so you can see that it's smoother, and these are the values, and this is the mesh. So that's actually, I think, yeah, you can see that how easy it is. And then using this, yeah, you can compile whatever you like, and with this FF C++ script, you can also pass, you know, some include states, some I switch, for example, I flag to include some headers if you want to compile some external libraries with that, or you can combine it with the codes that you have created. I told you that I will show you some more examples in the future. And in some of the videos that we'll have later in Talk Scenarios, we need to develop some plugins for FreeFEM. And by doing this, we can cover, you know, the shortcoming, the disadvantage of FreeFEM, one of the drawbacks of FreeFEM that I said in the beginning of the video, that is actually you don't have access to the external world. But by doing this, by developing these plugins, you can easily interface your code to those external codes, let's say external libraries, frameworks, or whatever. So that's it. I hope you find this useful, and yeah, enjoy that. So yeah, see you in next videos.